Welcome to another HL7 tutorial video. Today we're going to be talking about receiving encrypted HL7 messages over TCP/IP using our core HL7 listener. Now, first, some dry stuff. HL7 as a worldwide standard for exchanging messages over TCP/IP does not support transport layer security. That's encryption of any kind. For the HL7 standard TCP/IP exchange, the listener should just be a regular TCP/IP listener. That's the TCP/IP standard. The same type of listener used by almost every piece of network communication software, like Microsoft SQL Server, IIS, email servers, etc., etc., etc. Now, this is not an oversight. This is by design. The why involves a lot of history with how HL7 was created. But this doesn't mean that security and encryption or restricted access for HL7 data isn't required. On the contrary, it's absolutely required. It is just not part of the HL7 standard. Now, what we've done for the core HL7 listener is implemented a TCP/IP standard, secure encrypted TCP/IP listener, using a certificate, an SSL certificate, as other commercial software vendors have done. While doing this, creates a HL7 listener that is not HL7 standard because it's encrypted. It does adhere to the worldwide TCP/IP standard for secure encrypted data transfer. Now, what does this look like? Let's take a look. Here's my core HL7 listener. If you're a client, you're familiar with this, or if you've downloaded it and played with it. Here we're looking at a listener profile for Children's Hospital, EMR. This is an HL7 standard TCP/IP listener. It is not secured with an SSL certificate. In this newest version, here's Auckland Women's Health. It is secured with an SSL certificate. That means that any data coming into this listener will be encrypted. Now, for Children's Hospital EMR, this is not secured by SSL. Does that mean that this listener is not secure? No, it does not. If I am in Dallas and Children's Hospital is in Chicago and I need to receive HL7 messages from them, I would set up a secure VPN and allow Children's Hospital access to it. They would connect to my VPN and send me HL7 messages through that secure VPN. Let's see what that looks like. So here's an example of a VPN in this image here. My HL7 sender's in Chicago. I'm in Dallas. I would host a VPN with a secure tunnel. My HL7 standard sender customer, Children's Hospital in Chicago, would connect to my HL7 listener through the VPN and transmit data. The data is secured by the VPN itself, and that should adhere to any federal, state, local HIPAA regulations that you might come across. So the question is, if I have this, do I need this? And the answer is maybe not, possibly not, probably not. But there are business cases where you will want to do this inside of your own network or WAN. If, in this case, if I was Children's Hospital and I'm Children's Hospital Radiology and I need data from the EMR and we're a big company and I'm off in another building, so it's traversing my network, I might want to implement SSL so that even within inside my own company or my own network, my data is encrypted from end to end. So let's make Children's Hospital EMR a secure listener. Now, if you're not paying attention or you're drinking coffee, put it down, don't blink, or you'll miss this. All I have to do is edit this profile, go to the SSL TLS tab, check secure this listener with an SSL TLS certificate, and say I want to use this default certificate. Click OK, and I am done. I'm finished. This listener is now a secure listener. It is encrypted. I can click this badge, and it'll show you a report of the certificate that I am using. That's how easy it is. Now read this warning because it's important. Once you have an encrypted listener like this, no HL7 standard TCP/IP sender can send to it. Like this. This is our core sender. This is an HL7 standard sender. If I want to send to an encrypted listener, I have to create an encrypted sender. So let's dive a little deeper into how I set up my SSL listener. I edit my profile, go into SSL TLS, and all that I did here was click this button that says use the default core listener certificate. The core listener will create a certificate. It's good for 10 years. You can recreate it at any time. It's perfectly valid, but it is a self-signed certificate. If I wanted to purchase a certificate, or if I have certificates that my company uses, they have to be in the store. I click on this. You're probably familiar. This is all the certificates that I have on this computer, so I could go in and choose one of these certificates, and it's done. I've changed the certificate. This video isn't intended as a tutorial on what exactly an SSL TLS certificate is, whether you should use ours or buy one or use your own self-signed certificate. We put all that in the online help. Go to the Tools menu, SSL Utilities, and open the online help for the core HL7 listener. And you'll find things like third-party vendors. Here's just 3 of the top ones. We don't get paid by them. We don't endorse one over another. Here's just the top Google searches for purchasing certificates. I'll go to this one at random, and it says, oh, you shop for TLS certificates if you wanted to buy one for your computer. You can also create your own certificate. We provide a utility. There's other ways to do it. This makes sure that the certificate is good for sending HL7, receiving HL7, or sending and receiving HL7. Refer to the online help for the core listener if you have any questions at all, and then you can contact us as well. All right, so we've created our secure listener. Let's run it and test it. For that, I can just click the run here and say I want to start it. It tells me it started listening on port 6101, and it's SSL enabled, and it shows me the certificate that it's using. So we'll just leave this over here. Now we need a secure sender to send to it. We're going to use our core HL7 sender. Right now this profile is a standard sender, so we're going to make it SSL. So we're going to say the target listener requires an SSL. It's one-way encryption, which means only the listener has a certificate. I'm going to trust any listener certificate that is there, and I can say I want to ping it, and it says, okay, let's try it. So yes, there is a listener running. Shall I attempt to validate a successful TLS handshake? That's the secure connection. Yes. It goes off, and it'll come back, success. Secure connection was established. This is the certificate that it found and when it expires. So I say, okay. So if I say okay here, now this is an SSL sender. So I can run this. Now this is looking for HL7 messages in this folder to deliver it on this computer to port 6101. I'm going to run it. There it is. It's running. It's looking for HL7 messages. Now luckily I have my free core HL7 viewer loaded up. It's got 2 messages in it. I'm going to export everything to that folder. I don't need to open it up. Now, our sender should find these messages, and there, it found them, it sent them, they're gone. Our listener received the messages, acknowledged the messages, and etc. So that's done. If I do this and I go into this data folder, there are my 2 messages that I received. Now, the last thing we're going to cover in this deep dive video, it's getting long, is two-way TLS, bidirectional TLS, and what that means. What we've set up so far is one-way TLS, and that's where the HL7 listener handles the encryption. It requires a secure connection. It has implemented its own certificate, and it presents that to the sender during what's known as the TLS handshake. In two-way TLS, that's where the secure listener requires that the HL7 sender also have their own certificate, which they present to the listener during the handshake. When you do this, it locks the connection down. The listener will not accept secure connections from any sender which doesn't use that expected certificate. Let's look at how that works. Implementing bidirectional TLS. It is fairly easy. I go to here. Here's my listener is all set up. I just have to check this box. This is require the senders to also have a SSL TLS certificate. And what I specifically need from them is at the very least their thumbprint. So for this, if you do this, you have to coordinate with your client, your trading partner, the people sending you HL7 messages. So for instance, let's watch a failure just to be safe. Here's my children's hospital. This is a secure connection, but it's not bidirectional. If I look at this one, which is actually going to a different port, this is a bidirectional one. So I'm just going to edit this just to show. All right. Now I go to the client, my SSL certificate, and this is the one. They need at least this information. Now, the best way is just to export the client certificate public key information. It creates a cert file with just the public key, which the core listener can import, or it'll create a text file that's human readable. It's very, very simple. I'm just going to take this thumbprint and copy it to the clipboard. So I'm going to come over here and I'm going to say, okay, let's add this. Lots of ways to add it. You can add a thumbprint. You can import a cert. If it's in the store, if this was on the same box, I could go into here and get it. But nope, I'm just going to add the thumbprint. So I'm going to paste that in. I'm going to click OK. Since I didn't have a cert, I'll give it a name. There. Done. At this point, only a sender that is using this certificate can send to me. So if I click OK, and let's run this. Now it's bidirectional. If I look at the report, it says, yes, require client certificates, and I need it with this thumbprint. So let's go over to our core sender, and we'll go to the one we care about, Children's Hospital. See if I edit this, it's still set to only the listener. So what happens if I ping this listener now? Oh, it's not running. We'll come over to here and run it. Run. Start. Okay, so now my listener is listening for connections from this certificate. So I'll say yes, go. There is a listener running. What do I do next? Click OK. It says, do you want to do the successful TLS handshake? Say yes. It's going to go out. It's trying to connect to the listener, and it fails. And it gives you a message that the connection rejected, likely client certificate mismatch. Okay. So that failed. Let's go to our listener. We're going to stop this running, and we're going to go back into it. What I need is the certificate that this sender is using. So I'm going to go back into here. There's my add edit, and I say Over here in this, I say it's a mutual TLS. I'm going to just use the default core sender certificate. That is. There's the thumbprint that I need. So I can add this. Come over here and say, paste that. And okay, since I just had the thumbprint, I have to give it a name. Children's. It's there. I click OK. Save that. I'm going to run it. Now it says it started. It accepts from those two. So I will try now to ping again. Yes. There is a listener running. Validate yes. And this time it should come back and say success. And that's done. I just click OK. Now this secure sender is a bidirectional. We'll run it and watch what happens. There's my children's hospital. I'm starting it. It's looking for HL7 messages. Once again, I'm just going to go export these two messages to a folder. I don't need to do it. It should pick them up. It's already done. Picked them up, sent them, got the acknowledgments back. Totally secure connection from end to end. This sender could be in Chicago. This listener could be in Dallas. It could be going through a VPN, doesn't matter. The connection is encrypted. And that's our video for the day. If you have any questions, contact us. Visit our website at transworldscribe.com. Download these products and play with them. And if you have questions, contact us. And don't forget, leave a like, consider subscribing to the channel. It really helps us out. Thanks a lot.